Dear AI aspiring engineers, welcome to our channel Alex Tech Project. Today we try to see transfer learning, especially fine tuning the model for a given data set, which is nothing but the fine tuning. So here in this fine tuning, we are using the VGG16. The VGG16, it is already trained on a 1000 class images with the input size of a 224 with the channels as a 3. That is nothing but the RGB. So this is the VGG16 architecture. In the fine tuning, what we try to do, we try to keep this layer, this layer, and this layer as in a common, and we try to remove this state and hand over how many classes it has been there. So from here, after the flatten, we try to write the code, or we try to include our own dense and output layer. Now these are the input Python modules. So NumPy, OS, CS2, Pel image, Matplotlib, TensorFlow. So we are using. From TensorFlow, Keras application, VGG16, we are importing the VGG16 and the process input model dense flatten. All these things we are taking from the TensorFlow and from Keras. This is it. Now we are going to the train model, the VGG16 model. That summary we are giving. It is downloading the weights, you can see, and we are seeing the summary. So now you can see input layer, shape 224, 224, 3, and this is convolution layer 1, 2, and max pooling 1, 2, max pooling, convolution 1, 2, 3, max pooling, convolution 1, 2, 3, and max pooling, and convolution 1, 2, 3, and max pooling. Up to here, we try to keep the entire model as it is, and after this one they are flattening and they are creating as 1000 classes. So this much we try to remove it, and here we see trainable parameter 527.79 MB, non-trainable parameters as a 0, and model which is a 16 include top is equal false. So we are deleting this one. You can see this one we try to remove it. Input shape and model dot summary we are seeing. You can see up to the max polling it has been there. The rest of the things it has not been there. So means up to here is there these four: flatten, FC1, FC2, and predictions. So these things it has been removed by using include top is equal false. And now from the model layer -1 output we are making as a flatten, and after that one you can write the dense and you can write the whatever the dense layer and output layer. So we have to classify the 5 types of a flower. So I am using the output layer as in 5 and activation as a softmax. So now I have given the model summary. You can see it on the screen. Okay, after this flatten, you can see the flattening and dense layer 5. This is the output. So now you can see the trainable parameters like this, and non-trainable parameters is 0. Now if you count these layers, or if you remember the layers name, until you come black 5 pool, you need to make it as a layer trainable is equal false. Somewhat you need to come to up to this all these things should not be trainable, so we have to make it as a false, and model dot summary you can give it. Now you can see non-trainable parameters it has been increased, so we need to set this one up to what point it should not be trainable. That means trainable is equal false. This is a very important step. And after this one the model is the architecture is ready. From the transfer learning we have fine-tuned the model. Now loading the flower data set. You can see this is the URL. From this one I am downloading. It is getting the tgz. So this is the file tar file, and after this one how to segregate the flower into each directory. So based on the data set how it has been there, so this is something by using the glove, whatever the files images it has been there roses, I am giving into the this roses as a key, and the files which is there inside this one as an image files, and daisy, dandelion, sunflower, tulip. So like this I am keeping, and here I am keeping as a numbering number of flowers, and then roses is 0, daisy is 1, like this I have given. And this is the a for loop for, for each flower, and there it was taking using the im read cv to resize and appending to x and y append the flower numbering. So like this I am creating the x and y. X mean train, y mean label, that is input is x, y is the label. And train test split I am doing, you can see it on the screen. And I am pre-processing because this is the image 0 to 25. I am dividing with as in a 255 so that it values lies between 0 to 1. Now we try to fine tune the model. So model dot summary again I am giving, you can see whether the model is ready. Now model.compile Adam and loss function metrics and model.fit x train scale y train and validation split 0.2 epochs I am giving as in a 10. You can see it on the screen. Now defaultly the minimum batch size is 32, so it will try to divide and do. So epochs will be the 10. So you can say epoch number 2, 3, 4, 5, 6, 7, 8, 9, 10. So the accuracy will be 0.991 and validation accuracy will be 0.82. And model dot evaluate, you can see it on the screen. We have drawn this thing. So you can see accuracy should has to increase, validation accuracy should has to increase, and you can see the loss, it has train loss and validation loss also it has to decrease. So now this is nothing but the fine tuning the model on a given data set, which is the flowers, which has 5 times. You can see it on the screen. So this much I want to tell in this video. If you have any doubts, please let me know in the comment section. Thank you very much. We try to meet in the next video.